So now we're going to dive into the wonderful world of memory forensics and see how it ties directly into threat hunting as far as one of the key capabilities and skill sets. This is going to be a fun section. You're definitely going to enjoy the labs and the exercises. So let's get right to it. Why memory forensics? Well, most modern advanced threats live in memory only. I guess about 5 or 6 years ago, the term became popular: memory only malware. In other words, malware that lives and makes itself known only as it operates and propagates through memory. Most rootkits have the capability to only be detected through proper memory analysis. It's also effective on live systems, and it's minimally disruptive when you look at what the process is and how we do it. The best way to understand malware is to watch it work, and any type of ware, whether it's malware or just regular software, it works in memory. So getting arm around memory forensics is extremely important. Now, we're going to be using several tools, for example, Dumpit, and to dump memory, and Volatility to view it. And there's actually entire 5-day courses on using Volatility. Now, the Volatility Foundation itself offers a 5-day course. Last time I looked, it was taught by Andrew Case, and I've read some of his work and stuff, and it's definitely worth taking. I'm actually looking to take that memory forensics course myself at some point in the near future, just to kind of see what's out there, because he is one of the core developers of it, and he's probably got some interesting input on how to customize it. So there was a recent case that we worked on where the customer data was being exfiltrated to a cloud service provider endpoint. Think Amazon, AWS, Microsoft Azure, Google Cloud. That's where it was being exfiltrated to. So based on the organization's SIEM configuration and the packet traffic retention policies, we were able to get our hands on a significant amount of the exfiltrated data. The problem is it was all encrypted. So after spending about 2 weeks trying to break it, doing all kinds of stuff, from calling in favors to sending samples to others to try to break, we were trying to break it specifically so that we could take it and end up with unencrypted traffic and PCAPs that we could then do analysis on. Well, finally, then we discovered that the encryption key used to encrypt and decrypt, it was using a very archaic method there. It was found in memory as a leftover artifact from when the malware was using the key for exfiltration. So after a few days of research, trial and error, we were able to use that key, extract it from memory to decrypt a large portion of the traffic that was exfiltrated, and we were able to give our customer a confirmation that yes, we are sure customer data was touched and exfiltrated. Without memory forensics, we would have never found that key and we would have never been able to decrypt it. So this is just one of many examples that I could give you of where we had lots of data, we had lots of systems, we had access to lots of traffic and lots of traffic logs, and one little missing needle in the haystack in memory is what allowed us to tie all those things together. So definitely a lot of reasons why, but that's just one example of why. Now, the way that we do it, we follow a process of first using a dump tool like Dumpit is what we'll use in this course to take a memory dump, or we could do a live investigation of memory as well. But in our case, we'll take a dump, and then with another tool called Volatility, we will analyze that memory dump to see if we can find anything in there that is of significance. Now, the current version of Dumpit supports Windows XP all the way up to Windows 10, and provides extra information during the acquisition, such as directory table information, debugging data structures, and some other things that's mandatory for working with memory analysis tools like Volatility. Now, Volatility in its own right is probably, in my opinion, the most widely used memory forensics tool. For one, it's easy to use. It's written very well. It makes a lot of sense. It's very portable and it's written in Python, and there's lots of plugins and lots of community support for it, right? So Volatility can analyze memory dumps from all the operating systems that you see listed here, including everything up to Windows 10 and Server 2016. Even Server 2019, I believe, is in the works right now as we record this. So literally every operating system you can imagine, Volatility is able to essentially look at the memory and do memory dumps, or excuse me, analyze memory dumps from that particular operating system and do a pretty good job of it. So some of the specific things that we like about Volatility is it's open source, it's easily customized, it's written in Python, tremendous community support, great for learning forensics, and just great for overall just getting your head wrapped around the wealth of digital evidence and digital information that you can find in memory about how certain pieces of malware and other threat types of activities are taking place, that you will only be able to get that insight from looking at it operate in memory. So what we have here are some key Volatility plugins, and these are essential pieces of Python code which adds or expands on the core Volatility functionality. There's Image Info. This is usually the first one you'd run, especially if you're not sure which operating system generated that memory dump, or which operating system that memory dump came from. Usually you'll know, because if you're the one that ran dump it or whatever to get the dump, you know. But sometimes we get memory dumps and evidence and it's not tagged as far as which OS it came from. For example, there's one big customer we're working with that's got this e-discovery product that they run live in their network constantly. And what happens is anytime something that meets a certain level of suspicion happens on a system, automatic memory dump is taken and thrown into a network storage location. So we had access to these, and we pulled, the ones out that where the systems were based on, support logs and things exhibiting some behavior that we had discovered to be a specific threat. And what happened was when we got the batch of these dumps of the machines that were behaving that way, they weren't really labeled in a way that told us like which operating system it came from and that type thing. So we did know which system, but we didn't know what operating system that system was. So we would have to basically get someone to go and correlate these dumps with a computer name, and then find out based on some other inventory that they got what operating system that computer is, which we couldn't even really trust that, because as we found out, some of it wasn't up to date. Like a system might have been Windows 7 and it's been updated to 8 and then 10 now, but that didn't get updated in the list. So we ended up just kind of en masse writing a little Python, our own Python plugin to en masse take these dumps and then do an image info against each one and give us a list of what operating system each memory image was. That tremendously sped up our memory forensics process in that particular instance. Now, image info is nice. Another tool that we use a lot, kind of again one of our first runs, is PS List. It is basically the same as going to a running machine, typing, going to the command line and typing task mgr to get task manager up, and then looking at running processes, right? PS List gives you the memory analysis equivalent of that, all right? So at the time of the dump, what processes were running on the machine. So it almost allows you to do a task manager in history, like go back in history and see what task manager would have looked like at the exact time that this dump was taken, okay? One that I like just as much or sometimes more is PS Tree. It's giving you a task manager view, but with the relationship between processes shown. So in other words, you'll see, this process spawned this process, which spawned this other process, which spawned this process. You'll see that tree relationship. And sometimes that's significant, especially when you see, for example, an instance of command.exe being spawned by WScript, which was spawned by some software that never spawns a command line, maybe Internet Explorer, something like that. It could be kind of a telltale sign that that machine got compromised or that threat entered the environment through maybe some vulnerability in the web browser, right? So these are little telltale signs that even if your malware detection and all that stuff fails you, you can kind of get a heads up on what's going on based on that. There's also PS Scan. It's similar to PS List, except it shows the processes that were previously terminated in addition to the ones that were currently running. So it goes back and looks at the processes that were terminated kind of recently. And sometimes that information is more important than the processes that were running at the time of the dump, right? So you need that visibility when you're doing real threat analysis. There's also handles, which displays handles or logical links, associations to files, registry keys, and processes. Another one of my favorites is Command Scan. It searches through CSRSSEXE for commands that are entered through the command line by an attacker or a user at that machine. There's also Consoles, which is similar to Command Scan, with the advantage that it shows not just commands entered, but also the entire sequence. For example, if someone entered ipconfig, Consoles would show both the ipconfig command being entered and the results of what that ipconfig command showed on the console, whereas Command Scan wouldn't actually show that. So again, they sound similar, but when you think about it in that context, you can see they're quite different. So that's it for these plugins, and we're going to continue on to the next set of interesting plugins for volatility. So continuing on with the interesting and very useful plugins, there's also ProcDump, which in volatility, ProcDump basically dumps a given process from memory to its native format to a location of your choosing. So let me explain what that means. It means we can take a process that was running at the time of the dump in memory, carve that process out of the memory dump, and write it to a file like on our desktop. And what we have is an actual live executable version of that process. That's a very powerful plugin and very useful. We use this quite a bit when we find something that's suspicious or we don't know what it is in memory. We can ProcDump it right out and then actually put it in a sandbox and launch it and see what it does. Very useful feature there. There's also File Scan. Okay, File Scan is very useful as well because it locates any open files at the time of the dump, even the files hidden by the kernel level rootkits. All right, so even those can't hide from it, which that's a very significant point there that we'll see later. There's also dump files. It dumps files from memory, including files that are cached, which may be missed by File Scan. So you really want to use File Scan and dump files in conjunction with each other, just so you don't miss any recent files or files that were cached that may not have been actually in use or open right at the time of dump. So that's very useful as well. There's also connections, which allows you to view TCP connections that were active during the time of the dump. Now keep in mind, connections is a valid plugin only for Windows XP in 2003. And I know you might be thinking, oh man, well, that would be useful to have in later operating systems. Well, there's also ConScan that finds current connections at the time of the dump, as well as previous ones that may have been terminated right before the dump. And it is for XP and 2003 only. There's Sockets, which is also XP and 2003 only. It finds any sockets and open ports. Now, to make us happy, we have NetScan. Okay, NetScans basically finds all the things that ConScan, sockets, and connections finds for Windows 2007 or Windows 2008, Windows 7, and later, everything after that. So it shows you the combination of connections, ConScan, and sockets, plus it actually shows you quite a bit more information, and we're going to see that when we look at when we use this tool in our memory forensics lab, because we're definitely going to spend some significant time getting comfortable and understanding how to use volatility. There's also the Print Key plugin, which is a dump specific registry key, which dumps specific registry keys to the screen so that you can see what happened to be in that registry key at the time of the dump. And again, there's a lot of threat-based relevance there when you look at what's happening in the registry on a system. Some of the things we've done very usefully is taking, a swath of like 100 machines dumps and dump specific registry keys from those 100 machines and been able to quickly identify patterns in the ones that, were compromised versus the ones that weren't, and create some pretty useful indicators of compromise for our clients' incident response teams.